to enabling prosthetics and orthotics at Beacon, Life Enabled, and East Point. Zac Holcomb spent the last 8 years enabling organizations with additive manufacturing through aerosport modeling and design. In his spare time, Zac is also a brand ambassador of additive manufacturing. He shares his experience on enabling AM with HP machines and his insights with his podcast. You can follow him on hashtag Think Outside the Mold. Welcome.
Thank you. How are you?
Good. How are you?
Great.
And I don't see anyone's screen shared yet. You don't
so
mind.
I can go ahead and do that.
Perfect. Thank you.
So what we're gonna do here, first and foremost, we want to go ahead and prompt everyone. We're looking for questions in the Q&A. We're gonna try and wrap as quick as possible so that we can do as many Q&A questions as that we can get to. And if we don't have any, we'll just make them up on our own, and we're gonna answer them, and we're gonna know all the answers. So it's gonna be really boring. So try and give us some good questions. Brent's going to give you a presentation here. He's going to show you some of the dynamic ankle foot orthoses that he's created and a little bit of run through on, I think, a recent trip to Guatemala. He's got some video to show and get him to work with the audio, and that's what's going on. So there you go.
All right. Can you hear me and see my screen?
Yes, sir.
All right.
Good to me.
Perfect. All right. Well, man, it's been a pleasure to watch all this, and kind of going after Ryan and Kevin. Man, that's pretty awesome. So, yeah, I wanted to talk about 3D printing dynamic foot orthoses. A lot of people talk about 3D printing prostheses, but the reality is that orthoses are actually more common and more needed than a prosthesis. So, before we get too far into that, though, I wanted to just share what an orthosis is and a prosthesis is. So if any of you guys have seen Forrest Gump, Captain Dan wears a prosthesis or an artificial leg, and Forrest Gump wears a brace or an orthosis. So I'm going to show you a quick way of how we do thermal forming, and this is of a prosthesis. This is Frank from Sunstone Lab, showing us how to do thermal forming. And so here's just a quick video of that. So what we do is we heat up plastic. This is actually in the jungle of Guatemala. That plastic gets really floppy. And then we pull vacuum on it, and it vacuums and goes down to the mold. So after that, we trim that hot plastic off with scissors. We finish it with some various grinding tools, and off we go. Now, as I said, I did a lot of stuff, in Guatemala, and it was super important for me in the digital space, specifically, to have a connection to the internet. But unfortunately, in the jungle of Guatemala, we just don't have that. So we needed to have a way that we were able to pretty much be off-grid. And one of the ways that we did that, and one of the exciting things, was we had an app made called DigiScan 3D for the structure sensor. Now, the structure sensor was awesome because it was really affordable, and we were able to get it in more hands. And as long as you stay in the iOS ecosystem, so to speak, you are good to go, and you don't need the internet. You're actually able to airdrop those files. The other thing neat about DigiScan, it's the only app that exports natively as an STL with the appropriate scale, and it just gives you a really clean scan. A lot of people say, hey, Brent, so how accurate is DigiScan 3D and the structure sensor? And my answer just drives them crazy, because I say, it's accurate enough. And so when we're talking in the prosthetic and orthotic world, you're dealing with a body that moves. And so the reality is plus or minus 1 millimeter is good to go. And you're going to get better results than that. But I always kind of default to this video. This young man lost his finger in a table saw accident. And here he is playing the guitar. We scanned his hand playing the guitar with his prosthetic finger. This was the very first one we did. It self-suspends, and here we go. We'll watch him play, and hopefully you can hear some of that. But he's using his finger. It's staying in place. and he's a super talented classical guitar player and really liked it. So is Digiscan 3D enough along with the structure sensor? I would say yes. But I know we've got some engineers on this broadcast here, and so I just wanted to give you some numbers as well. So the mold on the left is 375 millimeters, and then when we scanned it and take it digitally, we've got 375.36 millimeters. And to me, that's pretty good. Now, I wanted to share with you guys some before and after videos of some patients here. So here is a young lady that has an issue with her left leg. Her muscle doesn't actually pull her toes up. So you can see that, and we're going to see a slow motion video here shortly of her. So watch that left leg. It just kind of just drops. And the key for creating any of these orthoses is that we want to have symmetry with the body. Symmetry makes sure that you don't have any back issues, hip issues, knee issues, ankle. You're just all together. So here she is after the brace, and you can see the toes are picked up. She has plenty of clearance, very smooth. And you're going to see the slow motion clip here. Very smooth. And you see the dynamic nature of these multi-jet fusion AFOs. So this was actually the very first one I did. This was a difficult one that I did. She wanted a brace with her ankle with hiking boots. So before, and after. So pretty awesome. Was she walking the best that she could be? Does she need a different brace? I would argue yes, but we always hear in orthotics and prosthetics the brace that gets worn is the best brace for the patient. And literally she's been in all kinds of different braces. So this is a great one for her. And she's actually been in this one for almost a year and very active person. This is Penny. Penny actually works for East Point Prosthetics and Orthotics. On the left side, you see her current AFO, and on the right side, her new AFO that we made. And hopefully this video will play and give her some of the feedback here. All right. Well, Penny, you've had this on for a few minutes here. What do you think of this AFO?
I love it. It's phenomenal.
So if you can't hear the audio, she is saying it feels so light, it moves with my body.
Every time I step, I feel like
And it's just pulling her toes up. Now the interesting thing about Penny is when she came to me for the AFO, she's like, here's the deal. I want to have a brace that I don't need to wear a sock with, and I'm going to wear Kiva style sandals. And that is an orthotist nightmare, is hearing, hey, I'm not going to wear socks and I'm not going to wear shoes. Tennis shoes are what you need to do. And I said, well, hey, let's give it a shot. Let's try to multi-jet fusion something. And sure enough, it worked well. In fact, she just recently told me a story of she was out in the yard working and didn't realize how long she had been working in the yard, and she said the only way that could have happened was she was saving and conserving energy because of the brace. So it doesn't look like much, but man, does it make a life change. So the last kind of case study that I wanted to share with you is a software developer that I work with, Paris Butterfield, and we were going to try to have him on, but he is actually part of the conference, and he's going to be on the 5th floor after the presentations, and he'll be able to take some questions there. But Paris came to us, and these are his slides. He has Charcot-Marie tooth. It's hereditary. His family, entire family, has it, and he really had trouble with balance, walking, holding things. He almost had kind of a march to his walking because his ankles were very floppy. It also affects his upper extremity. So when we're making a brace, we have to take into consideration how do we actually make it easy for him to get the braces on. He's been wearing braces for a long time. He's been in a bunch of different braces. In fact, he pulled out some old pictures here. And if you take a look on the left and the right, these are some of his original ones, almost 3 pounds per brace. This was 7 years ago. We had two generations here. The first one he broke after about 2 years, and we did some pretty interesting modifications to get all that together. And then the one on the right is one that we most recently did with thermoforming, and it is still working well to this day. But we wanted to try something with 3D printing. And so at first we had tried something with PETG, and that was just a complete disaster. And this was three or so years ago. And then about 2 years ago, we went to a style that has a composite strut, carbon fiber strut in it. And it actually worked really, really well. And the neat thing about that one is that you can change the stiffness of the strut by changing the struts out. So it was definitely a modular design. Most recently, I used an Artec scanner and duplicated his brace to make some multi-jet fusion ones. And then on the right is the multi-jet fusion brace. And here is what I love so much is Paris literally tracks all his steps. And he has walked, and this was up until I think the end of 2019, he had walked almost 500,000 steps in the new multi-jet fusion braces, and that's without a failure. That is pretty incredible. And since 2016, he's walked over 7 million steps, going in and closing in on 8 million steps. I think that one of the neatest things that I hear Paris say is, if I had this technology back when I was a kid, my life as a kid would have been different. And that's a big, big deal. And that's what excites me about some of these kiddos now that may have the same diagnosis or similar diagnosis, is that this technology will empower them to be more mobile. I got a note that the video is kind of lagging on this. So what we'll do is we'll actually take Paris's video and we'll put it up on YouTube. I'll let Zach handle that. But essentially in this video, it shows him walking, how much more balanced he is. And again, just how much of a life change he made. And in closing on Paris, one of my favorite stories from Paris is he went to, he was flying to New York. This was when I first started seeing him about 6 years ago. And his mom was looking for him at the airport, and he literally walked right by her because she wasn't looking for him. She was looking for the walk that he normally presented. And this style of brace now makes him walk symmetrical. So when you actually have his pants down, you can't tell that he's actually wearing braces. And he just recently said he is now more comfortable than ever. And for the first time in his 30 years of life, he's been wearing shorts, and something that he's proud to be wearing braces, proud to be symmetrical. So truly life-changing technology and life-changing braces are being used in the additive manufacturing space. So with all that, I'm going to stop sharing that. And I think we can get back to some questions if anybody has questions. If not, we've got plenty to talk about.
Yeah, we'll just make stuff up. So you don't want that. You know how that goes. So I'll go over here to Q&A and see what we got. First question. Andera, do you want to do that? Just jumping in.
I can help moderate the
Fired
questions.
up. All right, cool. If you want to, go for it.
First one from Shane. Can you get some toilet paper here in New York City?
We can hook it up, man. We can hook it up. My brother saw a really funny meme the other day. It was someone cutting down some product, and he was cutting down the paper towel rolls in half and then selling them as TP. So for your entrepreneurial spirits up there in New York City, don't rule that out.
But following that, he says, but seriously, I follow both of you every day. Actually, everyone at Link 3D does, and we love and support you guys so much. What can we as an industry do to help the amazing things that you are doing at Additive America?
For sure. First and foremost, we really appreciate that. Thank you for following all the stuff that we put out. That's crucial. Like, without everyone following along with that stuff within the industry, there's no way that we can ever, as an industry, break through the social walls as an industry and get out there more into the mainstream. So I think that's something that all of us can do a great job of, helping each other. So I really appreciate that. Thanks for putting on this conference too. Great opportunity for all of us in AM and ONP, all of, everything being tied into this event benefits greatly. Ben, I'm sure Brent's got a few ideas for how you can specifically help out from a monetary value. I know, like, really helps us in our business model is we're packing an HP machine with prosthetic sockets, and there's a lot of room inside those sockets. So what really helps our business model and helps us to have the ability to extend the olive branch of the access of that machine to more patients is those filler parts that we can fit in there. So, we have a lot of folks and friends that follow us and really like what we're doing there from the patient perspective. And, their method of contributing is sending us that work, so to speak. So there's a commercial for you, but I promise that's the only one I got. Brent's got a good one, though, I'm sure. Go ahead.
No, I mean, I think just supporting us and we love to give information, love to give back. So sharing some of the stuff that we do, and we do a lot of stuff in the developing world. And we specifically focus with Life Enabled and EP Legacy, which is providing prosthetics for kids in the developing world, because these are such life-changing devices that you can literally take a kiddo from begging on the street to, hey, and this has happened, we've been in Guatemala since 2006, to, hey, I'm going to be a teacher or I'm going to be an accountant, and literally providing for their family. And so this is all part of kind of the heartbeat behind Additive America is we want to see a world where everybody has access not only to 3D printing, but to a prosthesis.
Awesome. Thank you, Brent. Another question. Do you guys have any data to show expected life of an MJF arrow or prosthetic?
Yeah, I can take that one. So the short answer is kind of. So we are very in tune with some of the testing that's going on. A lot of people will quote the ISO 10328, which really doesn't actually pertain to sockets, but there's some information that you can extrapolate from it. So for a prosthetic socket, for instance, what we do is we tilt the socket at a 20-degree shank angle and then push straight down, and then we do destructive testing. We see if it breaks. And what's interesting on these multi-jet fusion sockets is we get up to about 2,700 pounds, 1,000 pounds, and the mold that's actually in the socket pushing down falls out. So the plastic actually deforms enough to let it out, so it actually doesn't fail. So that begs the question is, should we be engineering these prosthetic sockets to fail at a specific point? Because if there is a force, say 2,500 pounds of force, vertical force, what's going to break first, somebody's leg or the prosthesis? And we would prefer it to be somebody's prosthesis. And a perfect example of this is we just recently had a patient that was in a terrible car accident. He takes his prosthesis off when he's in a long car ride. And they said that his life was saved because he didn't have his prosthesis on, because his prosthesis would have literally cut him in half. So this is some of the stuff that we're grappling with on the engineering side of these prostheses, because it's always been, let's make them as strong as we can to make sure they don't fail. And I don't think that's right. So on the flip side of things, on the orthotic side, this technology has only been around for 3 years. There's not been a lot of people actually doing this for that long. And so people like Paris and Robin, the people and Penny, they've been in these for a year to 18 months. So we can say that. And then Paris has actual data from his iPhone telling us, hey, we're at least at 500,000 steps. And that's pretty doggone good, especially when we're talking thin walls. I mean, we're talking 3 to 4 millimeters of wall thickness on these braces. That's pretty awesome.
Very cool. Hi, Janet. Oh. Brief cameo. Another question has quite a few votes. What type of advancements would you guys like to see with MJF? Speed, accuracy, new materials?
Yeah, take that.
For me personally, things that I'd like to see from MJF mainly are just it's just ways to work with folks that aren't using the service calls as much as other folks. That's the biggest thing. It's just a financial situation, more so less for the folks that have the machines and are tied into paying these fees every year to maintain their ability to print on their machine. So that's the number one thing in terms of not fun financials and just the fun stuff. I don't really know. I really like the system. Like I like using it. It's pretty, like once you figure it out, once you're relatively comfortable with it, it's pretty nice. If I was really picky, I guess I'd go with cliche answers like a larger build volume. But then we'd get into more heat issues. I don't know. The speed of the 5200 over the 4200 is really cool because it's printing in 12 hours instead of 18 hours for a full build, which is largely what we're printing. So there's that time savings, which is really awesome. So, the way that for us, for me previously, it was like, wow, as a non-business person, as just a person running a machine, I was like, wow, 5200, amazing, gotta have it. But now in a different role, being in like a CEO role, looking at all the numbers invested in that too, we're looking at the time for a full build for the 5200 versus the 4200, and then we look at the price of the machine. And in prosthetics, we've got time, we got to clear it through insurance before things are really, it's not tomorrow every single time. So 6 hours on a full build is not the biggest deal for us, but those are some shortages on that stuff. Materials, man, as the more elastomeric materials come out, things get more awesome. The TPU materials seem really awesome, especially when paired with the AMT like we've been seeing and playing around with. And then the most generic answer ever, can we get material costs cheaper?
Yeah. Well, and I think the other thing, Zach, that you didn't touch on is we have to have a lot of pieces and parts to make our HP machine work. So like, it's not just, hey, here's an HP machine part, or we're running, a third party or whatever you call it with Materialize, and you've got other things that have to go into that. And there's all kinds of things that go along with that. But the bottom line is the parts that come off of that machine are amazing. Yeah.
Awesome. Another question. Everyone loves to talk about the successes that have come from switching to an additive solution, but what about the failures? Have you had prosthetic failures? And what are the typical causes, if so?
You want me to take that one, Zach?
Absolutely.
All right. So yes, we do have failures, but I know this isn't a surprise to other people, is that there's failures with traditional manufacturing as well. So like just recently, I had a regular thermoplastic AFO that's from a very large provider fail on me after just really a couple months. It just kind of ripped and cracked. And we've had very similar failures, but the neat thing about our failures has been because we're actually trying to push the limits. So we're trying to make these so light and so thin, which is kind of opposite of what the whole field is doing. Now, granted, we're not doing this on, like, for the AFO side of things. They are critical, but it's not going to cause somebody to just fall over. These are not like airplane parts, but they are on people. So yes, we've had failures, but we can track the reasons of why it failed. So we've definitely made some design changes, and one of those design changes is, hey, We need to make sure we've got the appropriate thickness around all the trim lines. We don't want to go any thinner than this. We know where our forces need to be. And then we have to have all our stuff flow together. So it just has to, no sharp edges, no corners. It all has to flow. And then, of course, we just have to ask Zac, hey, man, is this going to work before we print it?
Yeah, they pin me with the, like, they try to always get me in on that extra responsibility. Like, they want the stamp. So if it breaks, they can yell at me and be like, you stamp the thing. But no, what he's saying, you know, a lot of that is, you know, seriously is, we are doing something that's completely new, and we don't know. Like, if we made everything at 4 millimeters forever and we walked around and we touted like we make everything 4 millimeters thick and it's as light as you can go, and then like in 18 months some other company is like, we make everything at 3 millimeters, did you guys even know that you could go that thin and you would have been fine? We'd be like, dang it, man, like, why didn't we? So that's a lot of our failures are coming from that type of a perspective, like he said. But it's allowing us the opportunity to document failures too, and dial in more of a recipe of, this is what actually is successful. More and more and more and more, we have these proofs and cases that this is working and these thicknesses, and, you know, this recipe works, so to speak. So that's kind of that's the root of our failures. But actually, we like them. We have a whole rack of failures at the office. So I think we might have more failed broken parts with glue on them than nice pretty parts. So they usually go out the door, and then we don't have time to print nice new ones to show for people. So.
So there is a question from Matt asking, how do you judge, gauge, or decide on thickness? Does a lot of that come from the experimentation?
Yeah, so a lot of that does come from experimenting, but the Multi-Jet Fusion Nylon 12 operates a lot like copolymer, which is our world, or polypropylene. And so we know what works in a traditional fabrication sense. And so with that, we actually will create thickness, knowing what we know about the plastics and knowing that nylon 12 operates like that. So there's some of that, and then really a lot of it is talking to other engineers and people that are doing some of this stuff. How are we I-beaming? Are we relieving and making sure that there's no stress risers, things like that? So you know, between myself, Zac, and Grant, I mean, we're talking to a lot of people and iterating very quickly to find a process that works.
Yeah, and we have Tyler as well. It's doing some design stuff, you know, on the side of things that Brent's doing, and so that's what's really cool too, is watching their ability to go in with the freeform software and the haptic device. And there, as a lot of us are very familiar in the engineering world with the parametric softwares, you would go in and select a plane or a surface and extrude it out another X amount, whatever you type in with the numbers. This is much different. You're able to grab a wand and basically massage the part where you want to add thickness. And so for us, it allows us to add more organic structures, and it allows us to add more triangles to the shape so that we provide less stress fractures and points of fracture and stress in that part. So that's how we're able to get away with doing extra things and going down to thin portions on the prostheses and orthoses that we're doing. So.
Awesome. One more question, I believe, before we're out of time. Is there any question that you have that you would particularly like to answer? I'll just pick the top one.
Let's see. Oh, anyway.
I think one of the most important things that I think Zac will preach, and you know, I will do the same, is one, there's a lot of value to having somebody professional do your parts. You know, Zac's been in with this industry really since its infancy, and he's really good at printing large parts. And there are some service bureaus that are really good at printing small parts, you know, tight tolerance stuff, and we do that as well. But what Zac does and how he orients pieces and parts is amazing. So I think the bottom line is, not all service bureaus are the same when it comes to prosthetics and orthotics. And I don't know that you will find a better value than Additive America when creating and trying to really help push the industry forward. Our biggest fear is somebody buying a machine, making prostheses, and not knowing how to make them and not knowing how to operate the machine, and the prosthesis fails, and then it's like Multi-Jet Fusion is just a failure, nobody should use it. That's truly is our biggest fear.
Absolutely.
All right. Well, thank you both, Brent and Zach. It was a great presentation. And thanks for joining us today. We are now going to get into our next presentation from Dimension.
Thank
So
you.
thank you both.
Hey, thanks, Sundar.
Thank you.